Hello students, welcome to part 1 of the chapter Electrochemistry. Our classes are based on NCERT syllabus. What is electrochemistry? Electrochemistry deals with the interconversion of two types of energy. Chemical energy into electrical energy and electrical energy into chemical energy. So it's interconversion between two types of energy, electrical energy and chemical energy. So there are two types of conversions. Chemical energy can be converted into electrical energy and electrical energy can be converted into chemical energy. Those devices that can convert chemical energy into electrical energy are called galvanic cell or voltaic cell. These devices are named after two famous scientists. One is Galvani and the other one is Alessandro Volta, both Italian scientists. They lived at the same time. Galvani was the one who laid the basic principles of electrochemistry, and Volta was the one who first constructed an electric battery. So the device is named after them to honor them. And what is the role of device? It will convert chemical energy into electrical energy. On the other hand, device that converts electrical energy into chemical energy is termed as electrolytic cell. So we have two types of cell doing exactly the opposite process. For galvanic cell, from where it is getting this chemical energy to generate electricity. So it is getting the energy from spontaneous redox reaction. Using spontaneous redox reaction, it is generating electricity or electrical energy. What does spontaneous means? Spontaneous means a reaction or a process that take place by its own. You don't have to supply any energy to it. Spontaneous process will proceed by its own. What is redox? Redox means a reaction where both reduction and oxidation takes place. So redox means a process or a reaction where both reduction and oxidation takes place. So in a redox reaction, if it is spontaneous, then galvanic cell can generate electricity from it. On the other hand, electrolytic cell uses electricity to carry out non-spontaneous redox reactions. What is non-spontaneous? Those reactions that requires energy. So electrolytic cell is providing that energy in the form of electricity. That electricity is used by the electrolytic cell to carry out non-spontaneous redox reactions. So we have spontaneous. Spontaneous, you can identify the reaction by simply mixing the reactants. That reaction will take place. Product will be formed. But in the case of non-spontaneous reactions, you just mix the reactant. Nothing will happen. There will be no product. If you are supplying some energy to it, then it will give required energy to it, then it will form products. That required energy is electricity. That's what provided by the electrolytic cell. Okay, this electrolytic cell you might have learned in lower classes by the name electrolysis. So electrolysis contains an electrolytic chamber. This chamber is filled with electrolyte. What is electrolyte? Electrolyte is nothing but substances that dissociate to give ions. Sometimes substances dissociate to give ions in water. Sometimes they dissociate to give ions in their molten form. For example, sodium chloride, NaCl. NaCl, if you are adding a little bit of NaCl into the water, it will dissociate into positive and negative ions, Na plus ions and Cl minus ions. Or if you are trying to melt it in the molten form too, they will form ions, Na plus ions and Cl minus ions. Anyway, the electrolytic chamber contains electrolyte, and to this electrolyte, two electrodes are dipped, and these electrodes are connected to terminals of battery, positive terminal and negative terminal. Electrode attached to the positive terminal will have a positive sign or positive potential, and that connected to the negative terminal will have a negative potential. Once when I switch on the battery, these two potentials start operating. Let's look into the negatively charged ions. Let's say that this electrolyte is NaCl. So NaCl dissociate to give Na plus ions and Cl minus ions. Once when the battery is on, negatively charged ions will move towards positively charged electrode. Negatively charged ion will move towards positively charged electrode. Why this ion has a negative charge? Because it has more number of electrons than the number of protons. More number of electrons than the protons. That's the reason for this negative charge. Once when it reaches the electrode, it will give away that excess electron to this electrode like this. So negative charge moves, and once when it reaches the electrode, the negatively charged Cl minus will give away the electron to the electrode and becomes atom, chlorine atom. Half Cl2 means it's one atom of the chlorine molecule. Okay. So in this process, chloride ion has lost its electron, or you can say, as far as oxidation number is concerned, its oxidation number has increased by 1. That is, it was -1 here. When reached here, it becomes 0. It was -1 for chloride, and when it lost its electron, that minus charge is lost and its oxidation number becomes 0. So the process where there is loss of electron, it's called oxidation. So what is oxidation? How can you define oxidation? Oxidation means loss of electron, and it can be identified by increase in the oxidation number. So if there is an increase in oxidation number, definitely there will be loss of electron. Then the process is oxidation. And chloride lost its electron to the electrode. That means oxidation is taking place on the electrode surface. And the electrodes where oxidation is taking place is called anode. So how can you define anode? Anode is an electrode where oxidation takes place. Now coming back to the electrolyte, there are positively charged ions. Let's imagine that it is Na plus. Why has Na plus positive sign? Sodium ions have positive sign. It's just because the number of protons for Na plus is higher than the number of electrons. So it start moving towards negatively charged electrodes, and when it reaches there, it will accept electron to remove that positive charge. So this is what happening here. Na plus at the electrodes will receive one electron and become Na metal. So if you look into the process, it has gained the electron. And if you look into the oxidation number, there is a reduction in the oxidation number. So +1 has reduced to 0. Then the process is called reduction. So reduction is defined as gaining of electron, or it can be identified by decrease in the oxidation number. Decrease in oxidation number because it is receiving a negatively charged electron. So that's how the two terms are defined, oxidation and reduction. And this electron, they get it from the electrodes. That means reduction is taking place on the surface of the electrode. And the electrode where reduction taking place is called cathode. So cathode can be defined as an electrode where a reduction is taking place. So in this process, in this slide, we have defined 4 different terms that is very important for you. First one is oxidation. What is it? Loss of electron. How can it be identified? It can be identified by an increase in the oxidation number. Second one is reduction. How can you define it? Reduction is nothing but gaining of electron or gain of electrons. And it can be identified by a decrease in the or a reduction in the oxidation number. If there is a reduction in the oxidation number, then the process is reduction. And we have also learned about 2 electrodes, anode and cathode. Anode can be defined as the electrode where oxidation is taking place. and cathode can be defined as the electrode where reduction is taking place. So the electrolytic chamber, in the electrolytic chamber there is reduction and oxidation, so you can call this reaction as redox reaction. So in the chamber redox reaction is taking place. This redox reaction is non-spontaneous. Why? Because if you just mix them, reduction and oxidation will not happen. Reduction and oxidation will happen only if you pass electricity through it. That means electrical energy is used to generate or to conduct a redox reaction, non-spontaneous redox reaction. In the previous slide we have seen the device using that is called electrolytic cell. So this part of the chamber is called the electrolytic cell. Now we have a battery here. Battery is producing electricity. So how is it producing electricity? There are certain reactions going inside the battery. They are spontaneous redox reactions. Spontaneous redox reactions, when you connect it to the electrode through the electrolyte, suddenly the reactant started mixing here. When the reactant started mixing, a redox reaction takes place, and as a result it generates electricity. So battery can be considered as a device that converts chemical energy from spontaneous redox reaction into electricity. So chemical energy is converted to electrical energy. Such devices are called galvanic cell. So in one process, electrolysis, which you have learned in lower classes, we now know that there are two types of devices for this to work. First one is electrolytic cell and the other one is galvanic cell. And also we have learned 4 different processes. First one is oxidation, then reduction, then anode, then cathode. Okay, coming back to electrochemistry, now we can say that electrochemistry is an interplay between electricity and redox reaction. Electricity can be used to conduct redox reactions, and redox reactions can be used to generate electricity. So there should be some common factor between these two, electricity and redox reaction, and the common factor is movement of electrons. What is electricity? It's flow of electrons. And what is redox reactions? It's reduction and oxidation. For reduction and oxidation to take place, there should be transfer of electrons. So flow of electrons and transfer of electrons corresponds to movement of electrons. This is how they are connected, and this is how we can interchange or we can interconvert between these two, between electricity and redox reactions. Okay, this slide has some selfie questions. This will help to recollect and review your progress during the class. It's a way to self-assess your understanding and thinking process. So what you have to do is, after pausing the video, read all the 5 questions. You just pause the video and read all the 5 questions carefully and try to find answers. It is always better to write your answers in a sheet of paper. So once after you complete your answering, you can continue or resume to see the video, class video, and you can evaluate your answers by yourself. So what you have to do, read the questions, pause the video, read the questions, try to write down the answer on a piece of paper, and once you finished, resume the video so that you can read all the answers or evaluate all the answers. So I think that you have got your answers. Let's try to check, verify them. The first question was, differentiate between reduction and oxidation in terms of their oxidation number. So reduction means oxidation number will reduce, and oxidation means oxidation number will increase. So this is how you can define them based on oxidation number. But what is actually oxidation? Oxidation is losing of electron and reduction is gaining of electron. So reduction is decrease in oxidation number or reduction in oxidation number. Oxidation is increase in the oxidation number. Name the device that converts chemical energy into electrical energy. Answer is very simple, it's galvanic cell. Some may write electrochemical cell. The answer is correct but not specific, because electrochemical cell includes both galvanic cell and electrolytic cell. So in broad sense the answer is correct, but you have to be more if you want to be more specific, the answer should be galvanic cell or voltaic cell. And the third one, redox reactions are carried out by the electrolytic cell. What type of redox reactions are carried out by the electrolytic cell? Non-spontaneous redox reactions. Fourth question is differentiate between cathode and anode. Cathodes are the electrodes where reduction takes place, and anode are the electrodes where oxidation takes place. So cathode is reduction electrode and anode is oxidation electrode. What are electrolytes? Substances that dissociate to give ions. Sometimes it may be in solution or sometimes it may be in the molten state of electrolyte. So substances that dissociate to give ions are called electrolyte. Okay. We'll pass on to the next topic, that is spontaneous redox reaction. We have seen in galvanic cell uses spontaneous redox reaction. So before going to galvanic cell, we will go and have a quick look at basic terms or basic understanding about the redox reactions and its terms used. So here we are considering a redox reaction in which zinc metal is dipped in copper sulfate solution. So copper is in the solution and zinc is out of the solution in the form of metal. You dipped it, still it is out of the solution, it is not dissolving. When these reactants are mixed, immediately the reaction proceeds. That's why it is called spontaneous, and you will get product. What happens? Copper, which was part of the solution, comes out of the solution in the form of a metal. Zinc, which was a metal, goes into the solution as a part of solution, and it is zinc sulfate. Next we are going to identify the species that has reduced and oxidized, because it is a redox reaction. So for that, first what we have to do is we have to identify the oxidation number of each species in the reaction. To identify the reduced and oxidized species, we have to first identify the oxidation number of each species involved in the reaction. So these are the oxidation number. How did we get it? Sulfate always have an oxidation state of -2. Copper, to compensate that, must have an oxidation state of +2. Zinc and copper are in their elemental form because they are metals, and almost all the elements have an oxidation number of 0. Zinc again is with sulfate. Sulfate always have a -2 oxidation state. So to compensate that, zinc will have +2 oxidation state. So we have got oxidation number for all the species. Now we have to identify the species that has reduced and oxidized. So copper, which was in +2 oxidation state, has gone to 0. That means it has gained 2 electrons. From +2 it must gain 2 minus charges to become 0. So it has gained 2 electrons and thereby it become 0. 0. The sulfate on the other hand remains the same. There is no change for sulfate. Zinc, which was in 0, has now lost 2 electron and become Zn2+. So that means copper, its oxidation number 1 +2 to 0 has reduced. So reduction has taken place for copper. So this is what happened. Cu2+ has gained 2 electron to become Cu metal. Whereas in the case of zinc, it has lost 2 electrons to form Zn2+. So since it is the gain and the oxidation number has reduced, the process is reduction. So this can be treated as a reduction half of the redox reaction. This is a reduction half, where Cu2+ plus 2 electron giving Cu. Whereas zinc can be considered as oxidation half of this redox reaction, where zinc, which was metal, lost its electron to form Zn2 plus. So lost electrons are always written on the right hand side of the reaction, and gained electron is always written on the left hand side of the reaction. You write a redox reaction, it's always like that. Now if you look into both half reactions, say let's take reduction half cell. If you take reduction half cell, you can see that there are two forms of same species. One is the oxidized form of copper and the other one is reduced form. What does the oxidized form means? Because you can see that while looking to the oxidation number, which is having higher oxidation number, Cu2 plus is having higher oxidation number, whereas Cu is having 0. Higher oxidation number, the species with the form with higher oxidation number is called oxidized form, and with lower oxidation number is called reduced form. So there are two forms of the same species in a redox reaction. The two forms forms an redox couple. So redox couple means same species having two different forms in same redox reaction. That's called redox couple. The difference between these two redox couple is 2 electrons. You can make it from their oxidation number. There is also one more redox couple in the oxidation half reaction, which are one is the reduced form of zinc and the other one is the oxidized form of zinc. Again, the difference between the two forms of zinc is 2 electrons. So if you look into both the redox couples, on the left you can see it is their oxidized part, and on the right it is their reduced part. So this oxidized part can potentially act as an oxidizing agent. So always remember, oxidized part is can always act as oxidizing agents. Whereas reduced part can act as a reducing agent. Oxidized part can act as oxidizing agent and reduced part can act as reducing agent. Among these oxidizing agents, which one acted as an oxidizing agent in this reaction? Cu2 plus has acted as an oxidizing agent. Because why it is an oxidizing agent? It is helping zinc to get oxidized. So that's why it is called oxidizing agent. So among Cu2 plus and Zn2 plus, which has undergone reduction, you can clearly see Cu2 plus has undergone reduction to Cu. Reduce. It has higher affinity for electron compared to Zn2 plus. Cu2 plus has higher potential to reduce. This is called reduction potential. So reduction potential is the ability of an oxidized species to get reduced. Cu2 plus has this high reduction potential. Now if you look into the reducing agents, which among them is good reducing agent? If you look into the reaction, it's clear Zn is the one that helped Cu2 plus to get reduced. So this is called the reducing agent. The other reducing agent is copper. Copper remained in the solution when the products are formed. That means which one has higher ability to act as an oxidizing reducing agent? It is zinc. So zinc has higher oxidation potential. So zinc, why oxidation potential? It is the one among the two that is oxidized. So it has high oxidation potential. So try to pause the video and try to convince yourself that you got the point. It's like this. In a redox couple, oxidized species is called oxidizing agent and a